Got another problem up here, and again, I'm going to suggest that you pause the video and try to work it out. I've given you here a line that is not parallel to this plane. You might want to convince yourself that that's the case, okay? And then I'm asking you where they intersect, okay? Now, lots of times we're going to be concerned about various things intersecting, and the basic technique is pretty similar in all cases. If things intersect, that means the equations that describe both things must be true. So we're essentially working with a system of equations. Now, exactly what those equations are might vary a little bit, because I might have parametric equations. Here I've got symmetric equations. Here I've got an equation for a plane. Sometimes we'll have vector equations. But see if you can figure this one out, then tune back in. Welcome back. Okay. So what I want to do, I think, is I want to convert the equation for the line from these symmetric equations to describing them in terms of a parameter t. So remember where symmetric equations came from. If we had parametric equations so that we were describing x and y and z all in terms of t, we could solve each of those for t, and then it's the same t for each of these. Okay. So if x minus 3 over 4 is equal to t, that's equivalent to saying that x is 4t plus 3. Similarly, if y over 5 is equal to t, that's equivalent to saying that y is 5t. And if z minus 1 over 2 is equal to t, that's equivalent to saying that z is equal to 2t plus 1. So here I've gone to the parametric equations for my line, and so now I've got to have this way of describing x, y, and z, but if I'm looking at a point on the plane, this equation has to be true. Well, right now this is an equation in two variables, but if I plug in what x and z are in terms of t, it becomes an equation in one variable that I can solve. Okay. So 4t plus 3 plus 3 times 2t plus 1 has to equal 4. So that's 4t plus 3 plus 6t plus 3 is equal to 4. 10t plus 6 equals 4. 10t equals negative 2. T is equal to negative 1/5. Now be careful, that's not my answer, because that's a time. Now, the parameter doesn't have to mean time, but very often it does. But it's not a location in 3 space. I wanted to know where the line intersects things. So that's going to be at a point which is going to have an x, a y, and a z value. So I'm going to simply need to plug back in that t is negative 1/5. So my x value will become negative 4/5 plus 3, which would be 15/5. So that's going to be 11/5. My y value is 5 times negative 1/5, so that's just negative 1. And my z value is going to be negative 2/5 plus 5/5 would be 3/5. So that's the answer to that equation. Now, I'm not going to create a video for every type of problem we could have where one of these things intersects one of those things. But you're always essentially solving a system of equations. Keep that in mind and just figure out what you need to adjust when you've got different sorts of equations for different sorts of objects.